guys. So today we're going to do some more solving trig equations. It's going to be very similar to what we did last class, except we're going to look at a couple different strategies for solving. The first one we're going to look at is factoring, and then we're also going to look at maybe using some of those trig properties that we used in the last unit. So the first thing we're going to do is factoring. So before we can factor anything with the trig equation, we need to make sure we remember how to factor just in general. So first of all, remember whenever we're factoring, if there's three terms, first of all, we want to make sure it's equal to 0. Okay, it has to be equal to 0 before we factor. So then we look and see, first of all, is there a number in front of the x squared? If there is, what we do is we multiply the first and the last number together. We're looking for something that multiplies to that, so this should multiply to -2, and it should add to the middle number. So it should add to -1. Those two numbers are going to be -2 and 1. Then what we do is we rewrite the first term. Then what we're going to do is we're going to change the middle number into the two numbers we just came up with. So -2x plus x. And then we keep the last number. Then what we do is we use a process called grouping. So we look at these first two terms and we take out what's common. Both of those terms have a 2x. If I take out a 2x, I'm left with x minus 1. Then we go to the next two terms. There's nothing common there, so I'm just going to do plus 1, which is going to leave me with x minus 1. Since those parentheses match, that's going to be my first factor. Everything that's not in those parentheses is my second factor. Then to actually solve, what we do is we take each factor and we set it equal to 0 to get our answers. Now, this is a really common method we'll use when we have 3 terms for factoring, but there's not always going to be 3 terms for factoring. Sometimes you'll have 2 terms and you have to look at some other things. Now, in this case, there's 2 terms, and what you may notice is that these 2 terms have a GCF. We always look for the GCF first, and sometimes the GCF is all we can do. So in this case, both of these terms have a 4x that can come out. So 4x would come out. That would leave me, if I take 4x out of 4x squared, I'd be left with x. If I take 4x out of 8x, I'd be left with 2. Then we set each term equal to 0 and solve each one. So I would divide by 4 and get x equals 0, and I would subtract 2 and get x equals -2. So 2 different kinds of factoring that we're going to look at today. All right, so let's look at this first one. So this first one's going to be very similar to the exact example we just did, except instead of x, we have sine. So to make this a little bit easier to see, what I'm going to do is I'm going to pick a different variable to take the place of sine. Now, you don't have to do this, but it might make it a little easier to see how to factor it. You can pick any variable. I'm going to use u. The reason I'm doing that is just because you'll see u used in calculus, and also I don't want to use x because I don't want to think it's my answer. Okay, so I want to pick a variable different than x. So I'm just going to pick u, and I'm going to let u take the place of sine x. And this is not a step you have to do. This is just a step that's going to make it a little bit easier to see how to factor. So if I replace sine x with u, sine squared would become u squared. Sine x becomes u. And now you'll notice this is the exact same as the very first example that we did. So I'm going to go ahead and factor this. I'll go through the whole process again. Numbers that multiply to -2 and add to -1. Split up my middle into those two numbers. And then I do my grouping. So out of the first 2, I take out 2u. Out of the next 2, I can take out 1. Set each factor equal to 0. And I'm going to get that u equals 1 and u equals -1/2. Now remember though, we're not solving for u. That's why I picked a different letter than x. We're trying to figure out what x is. So at this point, I'm going to go back and replace u with sine x. And now we're doing something just like we've done the last couple classes. Since we're dealing with sine, we're looking for the y coordinate. So I want to know when the y coordinate is 1. So check your unit circle. You'll find pi over 2 as the answer for this one. And then -1/2 is going to be at 7 pi over 6 and 11 pi over 6. So this question has 3 different answers. All right, let's try this next one. So in order to factor it, I have to start by setting it equal to 0, which means I need to first subtract 2 from both sides. And now I'm going to be able to factor this just like I did the last one. So again, if you want to, you can replace that cosine with a u just to make it a little easier to see. You don't have to do this step, but I'm going to do it to make it a little bit easier to see how to factor it. Okay, this one's going to be easy to factor because there is no value out in front. So if there's no a value, I'm just looking for what multiplies to 3 and adds to -4. Well, that would be -3 and -1. So set each factor equal to 0. And remember, we're not solving for u, we're solving for cosine x. Okay, so we're looking for an x coordinate since we're talking about cosine. Now this first one, cosine x equals 3, that's actually not possible. If you check your unit circle, you won't see it, but it's also not possible because, again, remember what cosine means. Cosine's your adjacent over hypotenuse. You cannot have that adjacent be bigger than the hypotenuse. One that is possible, that's that very far point on your unit circle over at 0. So the x coordinate is 1 at the radian value of 0. All right, so let's try a couple more. Now this one is going to be a little bit more similar to the second example that we did, where we're going to do GCF factoring. All right, so here it's equal to 0. All right, so we don't need to subtract anything, but we only have 2 terms. But both of those terms have a tangent in them. So I'm going to take that tangent and factor it out. If I divide tangent from tangent squared, I would still have tangent. If I divide tangent from tangent, I would just have 1. Then I set each factor equal to 0. So tan x equals 0. Tan x plus 1 equals 0. Subtract 1. So this first one, remember tangent is y divided by x. 0 divided by anything is 0, so we're looking for where the y coordinate is 0. That's going to happen at 0 and pi. Tan x is -1. Again, that's y divided by x. It's going to be a -1 at 3 pi over 4 and 7 pi over 4. So this question has 4 total answers. All right, now let's look at this next one. Now, one thing I will tell you is that this is going to be very similar to the example we just did, but there's a really common mistake. And what people want to do is they want to divide by cosine. We cannot divide by a trig function. That's going to make you lose part of your answer. So what we want to do instead is we want to subtract it and move it all to one side to make it look like the question we just did. So now we have 2 terms, and both of these terms have a common factor. Both terms have a cosine. So we're going to take that cosine and factor it out. So if I take it out of the first term, I'd be left with 2 sine x. If I take it out of the last term, I just have 1. Set each factor equal to 0. And solve each of these. So cosine is the x coordinate. The x coordinate is 0 at pi over 2 and 3 pi over 2. You get sine x by itself, so we would add 1 and divide by 2. Sine is going to be a positive 1/2 at pi over 6 and 5 pi over 6. So all 4 of these would be solutions here. All right, so now we're going to look at some of our trig properties to help us be able to simplify some of these. So something like this, what might make this first one a little bit easier is if we remember that tangent is the same thing as sine over cosine. So then at this point, we can take our cosines and cancel them out, and we just get that sine x equals 0. So we're looking for where the y coordinate is 0. That happens at 0 and pi. All right, now looking at this next one, what we want to do here is think back to our sum and difference properties. Okay, so if we remember, we've seen something like this: cosine times cosine plus sine times sine. You can pull out your identity sheet if you need it, but that is the same thing as cosine a minus b. So I can replace this as cosine 3x minus 2x. So all of this stuff on the left can be simplified to cosine 3x minus 2x. So what I'm left with then is the cosine of just x equals 1. This is an equation we've done a lot now. Looking for where the x coordinate is 1 and the x coordinate is 1 at 0. All right, so we're going to do two more that are a little bit tougher. It's kind of going to combine both of these things together. So looking at this first one, this one is pretty tough because we've got a sine squared and a cosine squared. So one thing I want to do to make this a little bit easier is to put everything in terms of the same variable. So if you remember your Pythagorean identities, sine squared plus cosine squared is equal to 1. So there's a couple different ways that we could work this out. What I'm going to do is I'm going to rewrite it. I'm going to make sure we remember sine squared is the same thing as 1 minus cosine squared. So I'm going to replace the sine squared with 1 minus cosine squared. Well, now we have some like terms that we can combine. So negative cosine squared plus 3 cosine squared would be 2 cosine squared. And now this is a problem like what we did yesterday. Let's get the cosine squared by itself. So minus 1 divide by 2. Since it's squared, we're going to square root it. And remember, that'll be plus or minus. And when we square root a fraction, we square root the top and the bottom. Now, this is probably not a number we're going to see on the unit circle, so let's rationalize. So we're looking for where cosine is plus or minus root 2 over 2. So that's going to happen in 4 places. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, let's try one more. So again, looking back to those Pythagorean identities, let's try to rewrite everything with the same trig function. So one of those Pythagorean identities was that tangent squared plus 1 was equal to secant squared. So that means that tangent squared would be the same thing as secant squared minus 1. So let's replace tangent squared with secant squared minus 1. All right, let's combine our like terms. So I've got secant squared minus secant plus 4 equals 6. Now remember, in order to factor, it has to equal 0, or it has to equal 0, so we're going to subtract 6. And then if you want to replace that secant with a u to make it easier to factor, we can. I'm going to go ahead and do that. So that would be u squared minus u minus 2. So this is pretty easy to factor. Multiplies to negative 2 and adds to negative 1. Set each factor equal to 0. So then again, remember, u is not what we're looking for. We're looking for secant. So we're looking for where secant is 2 and where secant is negative 1. Now remember, secant is the reciprocal of cosine. So that means if we're looking for an x-coordinate, as long as we take the reciprocal. So that would be 1/2. And then if we do 1 divided by negative 1, it's still negative 1. So we're looking for an x-coordinate of 1/2. That's going to happen at pi over 3 and 5 pi over 3. And we're looking for an x-coordinate of negative 1, which will happen at pi. So we end up with 3 total answers here. So these last two are a little bit trickier. Again, these are really good practice for those of you guys who are going into calculus. Kind of combines everything that we've done so far. But the biggest thing really to focus on for today is really going to be the factoring. So if you're struggling with factoring, make sure we can try some practice with some regular x values before we get into these trig functions. Other than that, it's pretty similar to what we've been doing the last couple days.